In this video, I'm going to discuss my implementation of a stack using an array. I'm going to use an interface that I created, as you can see, called MyStack, and then I'm going to discuss the MyArrayStack class, which is actually the implementation of this interface. So if you have not watched a video called Stack, this will be a good time to stop here and first watch the video called a stack, where I explain the operations on a stack and the 4 methods that I'm about to discuss, and then come back to this video. The implementation of the stack, the interface of the stack has essentially 4 methods, which are push, which we're going to use to insert new objects at the top of the stack, pick, that is going to display the value of the object at the top of the stack, pop, which we're going to use to remove items, objects from the stack, and finally is empty, which will answer that question in regards to the stacks. And this will become relevant in the array implementation because the array will have a finite site. Now I'm going to proceed to discuss the implementation of the stack using an array. For starters, the class is called MyArrayStack. Obviously uses an array to implement the stack. You're going to see a different video called MyLinkStack, and that uses a linked list to implement the stack. So I encourage you, after you finish watching this video with the array implementation, that you watch the video with the linked list implementation. And it's not a surprise, I am implementing the interface that just showed you called MyStack that has the 4 methods. My data essentially is going to be an array that I call the data, and that's a very simple array of generic objects. The initial capacity is a constant that I'm going to use when I create the array. So in other words, the data, which is the array that represents the stack, is going to have an initial capacity of 10 items. And finally, I need this integer that I'm going to call top of the stack, that is going to tell me what is the index where the top of the stack is located at any given time. One thing to notice is that this is initialized to -1 and not to 0. Why? Well, think about it. If I said that the top of the stack is located at index 0 is the index of the first element. That means that there is one element. It doesn't mean that the stack is empty. So at the very beginning, I need a value that is going to tell me that the stack is empty. Therefore, I cannot use 0 because 0 is a valid index. It's the index of the first element on the array. So when I start this class, the proper value will be -1 to indicate that there are no elements, not even one element located at index 0. So it's a very simple implementation. So I have a constructor called MyArrayStack, and all I do is to allocate memory for my array. So my array is called the data, so I'm going to say new, and I'm going to say object, because I need to have a generic array so that I can insert objects that I want later on. I'm going to use my constant initial capacity, and again I'm casting so that this is actually an array of generic objects. So it's typical traditional way of creating this type of array. So keep in mind that my array has a capacity of 10 values, 10 items. Then the method push is void based on all the discussions that we have. It takes one parameter, which is the object that I want to push into the stack, the object that I want to add to the stack. So my first thing is I need to test whether or not I have a space in the stack to store a new value. Remember that I'm using an array, so the array has a limited size, and I had set up my array to start with 10 elements. So after 10 elements, my stack will be full. My array has reached maximum capacity, so I will have to create a different array. So my first test is to say, well, let's check that index that represents the top of the stack, and if that index is equal to the size of the array -1, that means my array is full. All locations are being used, and I need to do something else. So what I'm going to do is to reallocate. In a couple of minutes, I will discuss that method, but that method, what it does in essence is to create a larger array, copy the values from the old one into the new one. Now, if this statement happens to be false, means I'm okay, I still have a space to add more elements to the stack. So what do I need to do? Well, remember, I'm adding at the top. So there got to be a top at this point. So all I need to do is to change the value of that integer that represents the top of the stack by adding 1. So top of a stack plus plus tells me the index where I should insert the new object. And then all I have to do is to copy the given object as a parameter into the location. So it's a very simple addition to an array, and it's very simple because I'm adding at the top of the stack, and this integer tells me where the top of the stack is at any given time. The next method is going to be the method pop. That's the one that we use to remove. And remember, I don't need to specify neither a location like an index or a value. It simply assumes that the only value that can be removed is the value at the top of the stack. So my first check is to determine whether or not I have at least one value in the stack. So I'm going to call the method isEmpty, which I'm going to discuss on the next slide. And that's going to be true or false. If it's true, then I'm going to throw an exception because there is nothing that I can delete. If this statement, this expression is false, then it means that I have at least one value. That value can be popped. And then what do I need to do? Well, I did it in one statement, but there's a lot of things happening here. First, there is a return, and the return is because my interface asked me to return the value that is deleted. So I have to return a value from the data. Which value? The value, the item that is at the top of the stack. So I'm going to use the value of the top of the stack. So this simply returns the object that is currently located at the top of the stack. And then what do I have to do? Well, because this is a remove operation, all I have to do is to change the location of the top of the stack. And to change the location of the top of the stack, I perform a minus minus in the value of the top of the stack. Be aware that the update of the value of the index is done after I return the value. So first I use the current value of top of the stack, then I subtract 1 from it. I could do this in different lines of code, but I want to simplify the operation. So this does two things essentially. One is return the value that is currently located at the top of the stack, and second, remove. But remember, the remove is simply by tricking the stack, changing the value of the index by subtracting 1 from it. The pick, again, all it does is to display. So all I have to do essentially is to say return the object that is located at the top of the stack. So I have this index, which is what the top of the stack is located, and then I have my array, and it's very simple. The only thing, again, I need to make sure that I have at least one element on the stack so I can apply the method pick correctly. If this expression is empty, says it's true, that means that I don't have anything to display, so I wanted to throw an exception. But other than that, it's a simply return a statement. Finally, I'm going to discuss the isEmpty and the reallocate. IsEmpty is a boolean, so return true or false. It should be clear what this does. And to determine whether or not the stack is empty, again, I'm going to use my integer called top of the stack. And if it's equal to -1, means that it's empty. Remember that that is the value, -1, that we use to initialize the stack. So if the top of the stack indeed is -1, that should be interpreted as the stack being empty. So this expression will be evaluated to true, and then I will return true. The reallocate is a method, again, that is needed, is used in the method push. Okay, I'm using an array, so it could be the case that I don't have any more space. So if the index that belongs to the top of the stack is equal to the maximum size, the maximum allocation that I have in my array, means the array is full, so I need to create a larger array before I push a new value into the array. So I'm calling this method called reallocate. So let's see how reallocate works. It's very simple. Okay, reallocates is a void method, doesn't return anything, and what it does is essentially to first create a new array which is exactly twice the size of the previous array. So this line is the same line that I use in my constructor. It's just that now, instead of using the constant that says create an array that has 10 elements, I'm going to say create an array that is twice the size of the current one. Once this statement is executed, I have an array called temp, which happens to have 20 elements because the initial array started with 10 elements. The array is empty, so now I need to copy the 10 values that I have in the old stack into this new array so that I can have 10 new elements in my array that I can use to add. And I'm going to use, very conveniently, a method that exists in Java called ArrayCopy that does exactly that. It copies values from one array to the other. What this statement is doing is simply copy the values from the old array, which is called the data, into the new array, which is called temp. So at the end of this operation, I have an array called temp that has 20 elements, 10 which are exactly the ones that I used before, and 10 which are now available for me to insert values into the stack. And then all I had to do is to switch the arrays. So the data after this statement will be an array of 20 elements, 10 of which are not used. So it's a very simple implementation of the stack using the interface that I created and using an array. Again, I encourage you to watch a different video called My Linked Stack, which has or uses a linked list to implement the stack.